Alright, one thing we did not get to the other day with the notes I left for you on Thursday. The very last thing was you had to evaluate a composition of functions. So this will be kind of good. We'll go back and review a little bit. For this one, we're going to do like we did yesterday. We're going to have the two functions where f of x is x minus 5. And g of x, we're going to make it x squared. And the difference on this one is instead of them having you just find where you're taking x minus 5 and plugging it in for x over here, or taking this x squared and plugging it in over here, they're actually going to ask you to find a specific value for this one. So it may be that they're going to do something like this. They may ask you to find f of g, but instead of just finding x, they're going to give you a number, -3. Now, or also at the same time, they may do something like this where you've got a double set of parentheses. And basically it comes down to this. Whatever this letter number is closest to, whether it's f of g, this -3 is closer to g, so the very first thing is you're going to plug that into whatever it's closest to. So since the -3 is closest to g, we're going to plug that into g first. And that'll be the case every single time when you go through these. So if they ask you to evaluate, where they give you, instead of just giving you an x value, they give you a number, you're going to take that number, plug it into the function that's closest to, whether that's f or g. So for this one, we're going to take the -3 and plug it in here. So everywhere you have x, you're going to take out the x and replace it with -3. And again, whenever you plug that number in, always put it in parentheses. So since g of x was x squared, we're going to take the x out and replace it. And remember, you do not do anything to this left-hand side. You're only going to work on the right-hand side. If you do -3 squared, that's 9. So once you've done that and you've taken care of the g of -3 for the g part, well, now you still have the f part. So now you're going to take this answer you have of 9 and you're going to plug this answer into the other function. So we're going to plug this answer we have from step 1 into the remaining function. So what we had to do back up here, we had to do f of g of -3. We took care of the g of -3. So now we're going to take this 9 and plug it into f. So we're going to take and plug 9 in for x in f of x. So f of x was x minus 5. So everywhere we have the x, we're going to take out the x and replace it with 9.
May I have your attention? Can I have seniors with the last name T?
So then you're left with 9 minus 5. So that would equal 4. And 4 would be the final answer that you want for this problem. So because there's two functions, because it's f and g, you have to plug it in twice. And you start by plugging in the number closest to what it is. And again, it'll either be written this way, where we have the f of g of 3, or it'll be written like this. And again, it always goes to the closest number. So if g happens to be here, it's closest to g, so you plug it in. If it was written the other way, where it was closest to f, you plug it into f first. So you're going to plug it into one function one time, get this answer, take this answer, and plug it into the function that's remaining. And that's going to be the final answer that you're looking for. And just so that you're clear on these when we go through this, if it's an open circle, that's when you know it's the composition where you're going to plug it in. When that's a solid circle, that's when you know it's going to be the multiply. So that's going to be the difference of the two. So when you have the open circle, that's when it's a composition. When you've got the dot where it's solid, that means you're going to multiply those pieces. Okay, so that was one small piece that I didn't get to yesterday in the 6.6 note. So this is going back and clarifying that part of it. For 6.7, it's inverse relation. And if you remember when we did inverse earlier, that was where everything was basically the opposite. If you're doing the inverse of addition, it would be subtraction. The inverse of multiplication would be division. So for these, what you're going to wind up doing is, for the inverses, you're going to wind up switching your x and y values. And when you switch your x and your y values, that means you're going to switch domain and range. So the very first thing they're going to have you do when we go through these problems is you're going to get a list where you're given a values of x and y. And they're going to ask you to find the inverse. And as long as we're finding the inverse for this part of it, it's going to be pretty much just like it is. You're just going to tell me these numbers and just reverse the order. So instead of it being 0, 1, when you do the inverse, it's going to be 1, 0. Instead of 2, 3, it's 3, 2. Instead of negative 4, 5, it's going to be 5, negative 4. And this would be negative 7, 6. Now, they may ask also for you to do these as ordered pairs. So if that's the case, then just do 1, 0, 3, 2, 5, negative 4, negative 7, 6. So giving you a pair of, or a list of ordered pairs, to find the inverse is really simple. Just switch up the x and the y values. So you're basically just switching your domain and range. Is another way they could list that one. Okay, now for equations, it's a little bit more complicated than that because it is an equation. So here's what we're going to do to find the inverse of an equation or a function. So technically we're finding the inverse of a function, but at the same time it's really just an equation. Step 1, you're going to replace f of x with y, because they're going to start you off with a function, so it's going to be f of x equals something. So the first thing is take out the f of x and replace it with y, which makes it an equation. Then you actually do what we did up here. Then you switch your x and your y variables. Then you're going to solve for y. And at the very end, the last thing you would do is once you've got it solved for y, you're going to replace y with f negative 1 of x. And that f negative 1 of x, that is your inverse notation. Or your inverse symbol, if you want to look at it that way. Okay, now, and again, because we're just switching these, when we find the inverse, everything that's being done to x is basically going to be the opposite of what it normally would be. The only thing on this one is that you have to just find the right order so that everything is set up exactly where it should be. Okay, so we'll go through this. We're going to give you one function here where f of x is x squared minus 1. They're going to tell us that the domain is negative infinity to infinity. And then the range would be negative 1 to infinity. Or at the same time, they may also say that y is greater than or equal to 1. Okay, so the first thing we're going to ask you to do is find the inverse. So this is where we're going to go through our steps and go through that. So the very first thing is step 1. We're going to take out the f of x and replace it with y. Second thing is we're going to switch the x and y. So x goes here and y goes here. Now you don't switch the operations, you just switch the variables. So wherever these are, just reverse these two so the x is here and the y goes there. And step 3, this is where we're going to solve for y. So now you've got to get the y by itself. So for this one, the very first thing you would do is you would add the 1 to both sides. And we've got y squared. We need it to be just y by itself. And the opposite, to get rid of a squared number, hopefully y'all remember this from the last test or two we've done. To get rid of y squared, we need to square root it. If you square root the right side, we also need to square root the left side. And when you do that, the square and square root cancel. So it's leave you with x plus 1 equals y. And two things are going to happen here. We've basically done everything here, so the last part is, for the final answer, that if you remember before, when we started with y squared, we needed 2 answers. Or back up here, when we started with x squared, we needed 2 answers. So for this one, to kind of include that part of it, we're going to put the plus or minus here. And normally we would just, we put the y first, but step 4 says instead of using y, we're going to put in f negative 1 of x. So if you need that step in between, basically we would be there. So we took out the f of x, replaced it with y. We switched the x and the y, and then we're going to solve for y. And again, if you think about it, everything should be the opposite operation. Back up here, the opposite of x squared is square root of x. The opposite of minus 1 is a plus 1. And it's always going to be that same way when you go through the inverse, that what you do in the beginning should be the opposite of what you do in the end of it. So instead of x squared, we square root. Instead of a minus 1, we do the plus 1. Now, the one thing they're going to ask you to do extra in the homework, once we get here, is they're going to ask you, is the inverse a function? And for this particular one, because we had the plus or minus, if we plug in a value for this one, we're going to get 2 different answers. Let's just say 0. If you plugged in 0 for x, you would do the square root of 1. But it could be positive or negative. So that's that part of we're getting 2 different answers if we plug in one number. So this one would be a no. If you don't have this plus or minus for the part of it, then you wouldn't have to worry about it. So if you start off with x squared back up here, because we had to square root it to take the 2 answers, it's going to be a no. And then the last thing they're going to ask you for is domain and range. And this is one where, again, you're just going to go back to the beginning. In the beginning, the domain was negative infinity to infinity, and this was the range. And the answer, we're going to flip-flop these 2 answers. So now those are going to be the opposite. The domain is going to be negative 1 to infinity. And your range is going to be negative infinity to infinity. Now, you also, for this one, because now we're talking about the x values, where this was y greater than or equal to 1, when you switch it to the domain, it also could be that you've got x greater than or equal to negative 1. give you another one here where we're going to go through and do the setup for finding the inverse. Let's go f of x is 6x plus 7. Okay, again, step 1, you're going to take out the f of x and replace it with y. Step 2, you're going to switch up where the x and y are. So the x is over here, the y is over here. And then step 3, now you're going to solve this thing for y. So you're going to subtract the 7. And then for this part, you're going to divide by 6. So that you can cancel out those 6s. So you're left with, and we'll put the y first, x minus 7 over 6. And you technically found the inverse, but the last thing for notation-wise that they want you to do is take out this y and replace it with f negative 1 of x. And that's the last step you have to do. Okay, now, and as far as the domain goes, if there's no, we don't have that plus or minus we did when we square rooted for this one. So if they ask you for this part of it, if this is a function, then we're good to go. So the only time this thing is not going to be a function is when we square root this one and you've got the plus or minus here. This one, when you plug in one number, you only get one answer because there's no plus or minus part of it out front of it there. Okay, and then the last thing, and we may or may not, depending on how far we get, we'll do this one, but this will just be a very, very, very brief thing here. In 6.8, and we'll decide later on if we're going to do the homework on this one or not. To ask you to graph a radical function, we're going to do just a very basic one, square root of x. So if you remember from what we did in the past, if we were square rooting this one, you always needed the number to be 0 or positive. If we took the square root of a negative number, if we square rooted negative 4, that made it where it was not real. Now, it was imaginary, it was 2i. But there's no way you can graph the number on just a plain number line. So for these, when we're graphing these, we're only going to have a graph that looks something like this. If it's just square root of x, you're going to start at 0, and it's going to slowly kind of arc up out this way. And if you want to make a little chart just to kind of get the numbers for this one on the graph, we'll do the numbers that we could do. If you took the square root of 1, that would be 1. So that would basically be this point that's here at 1, 1. If you took the square root of 4, that would be 2. So that would be the point that's at 4, 2. The next point we have, which would be kind of off the graph there, if you take the square root of 9, that would be 3. So you'd have to go all the way out here, 5, 6, 7, 8, 9. And now you've only moved up to the third point, which would be about here. So it's one of those graphs where when you get to the end, this thing starts to get really flat as the farther out you get. It has a nice little curve in the beginning, but then it flattens out as you go throughout the rest of it. And that's just the basic shape of it. If you have to do anything with it, all the graphing, all the moves we're going to do, it's going to be the same thing as we've done in the past, that if you put a number on the inside of the graph, We did this where we added or subtracted a number on the inside. If you remember when we're doing the quadratics, that's going to move the number 4 spaces, but in the opposite direction. So we're going to take this graph we have, and we're going to shift it 4 spaces to the right. So we would take this graph that we had here, this exact same graph, but we're going to, instead of starting at 0, 0, we're going to start at 4. And it's going to have that same exact curve that's going to go off in that direction. And then the same thing would be if we added a number on the outside. If we did square root of x plus 3, if that number is on the outside, we would take the original graph we had that started at 0, 0, but because it's on the outside, you would scoot it up 3 places. So this one would start here and have the exact same curve and exact same graph going that way. So as long as you do the square root of x, it's always the exact same curve. If it's just here, you start at 0. If the number's on the inside, just like we were doing things before, anything on the inside moves it left or right in the opposite direction. Anything on the outside moves it up or down. And that is the end of the notes for today.